Alright, and we know that in machine learning we always have an optimization problem. So we need an objective function or a cost function. And this is not different here. So your cost function in this case is going to be a function of the CYs. And remember, the CY is the index of the cluster Xi belongs to. Yeah? For example, X8, C8 will be 2, because 2 is the index of the cluster that X8 belongs to. Okay? And then we also need to do it respect to mu k. This is the centroid k. And it's not so difficult. It's again 1 over n when you have n samples. And here I is going from 1 to n. And then we take the distance between your point xi and the cluster that xi is assigned to, and we square. It's quite intuitive and quite obvious. So basically what you do is first you assign xi to a centroid to mu k. So here you do minimization of with respect to the CIs, and then in a second step, so this is step 1, and in a second step what you do is you move your clusters uk to uk new. Yeah. So here you minimize with respect to your mu. Mu goes from 1 to k. Yeah. So that is the objective function, and that's how it works. So you have an assign step and you have a move centroids step. Alright, so things don't always run perfect in k-means, so there's some issues that we need to tackle. Let us take the initialization phase. So basically we're going to random pick 3 centroids in this case. Yeah. So let's assume that the first centroid mu1 is here, the second centroid mu2 is there, and mu3 is there. Yeah. So what's going to happen in this case? Well, you're going to have probably clusters that go like this. Yeah. So basically what you could have here is a local optimum, because obviously the better choice would have been 1 cluster, 2 cluster, 3 cluster. Yeah? So you could get stuck in a local optimum. How to solve? Well, one way is to pick training samples as your centroids. Yeah, in this case you won't have this, your mu will basically be on a point, but you could still have issues. Yeah, because you could still initialize, for example here, you could still initialize mu1, mu2, and mu3, right? If you pick training points, this could be the situation. And this is also not something that you want. So pick training sample is one. Another option is run initialization several times and calculate the cost. Okay, so this will help you. And you look for the most optimal cost of, maybe you do 100 initializations. Yeah. Now, how much is k here? Well, how much is k? Well, it's obvious that k should be less than m. Yeah. If k equals to m, you will have all clusters with one data point in k-means. But here is a typical example, right? Here you have two options. You could say, oh, but these are two clusters, right? Like this and like this. Yeah, but also you could say no. So this is case 2, two clusters. But you could also do case 4. And then this is 1, this is 1, this is 1, and this is 1. Yeah. So k is a sort of hyperparameter that you as a data scientist need to choose. Another way is something similar of what we've done here is you run the algorithm a few times, every time for a different value of k. And typically what you would see theoretically is some kind of this we call an elbow curve. Elbow. Yeah, so basically here is probably the optimum point. After that your cost still goes down, but not significantly. Yeah. But in reality what you will see more something less obvious. Yeah? So it's not that obvious to choose what k is gonna be the best. Yeah. So usually it's a combination of these techniques compared to augmented with your personal beliefs. Here, for example, you have a t-shirt manufacturer, and here you have the height of a person, and here you have the weight of a person. Yeah, and this will correlate positively with the size of the t-shirt. You could say I want small, medium, and large. Yeah, then you have something like this. So this could then be small, could then be medium, and this could then be large. Sorry, there's no overlap, right? But you could also have extra small, medium, large, extra large. Then you would have 1, 2, 3, 4 clusters. Yeah. So here it's a little bit the gut feel of the person that needs to do the clustering. Keeping the end goal in mind. All right. So that was all about clustering. We're gonna do a coding exercise on clustering, and see you next time.